cats and rabbits who reside in fancy little houses, and be dressed in shoes and hats and trousers. In a world of my own, all the flowers. I wouldn't be here. That's just the trouble with me. I give myself very good advice, but I very seldom follow it. That explains the trouble that I'm always in. Be patient is very good advice.
Of course, he's mad too.
But I don't want to go among mad people.
Oh, you can't help that. Most everyone's mad here.
What's going on, everybody? Thanks for tuning in and watching this new stream we've got going on. If you're new to this, you guys haven't seen this before, you just saw this random link out there. Hi, hey, hello, we're the Neon Temple. We are a local cybersecurity guild out in Tampa. For those of you that know us, you know what we're about. You know we're all already a little mad down here in the temple, so it's kind of a fitting theme for the start of this series. I'm Treycraft. I'm here. I'm going to introduce the series to you guys for a little bit real quick. I'm going to introduce Dr. Sunny herself and your host moderator tonight, Coach Eyes. And then I will let you guys get to what you actually care about, listening to Dr. Sunny and learning how to smuggle some HTTP requests. So this is a new series we're trying out here. Dr. Sunny, our awesome guild matriarch, has offered to put this on. She's trying to pass on some knowledge that she's been keeping up in her brain housing group, and she would like the rest of you guys to know what she knows. So tonight, we're going to start this off with HTTP request smuggling. As this runs and keeps going on, it's going to change. Topics will vary month to month, and I think it's going to be an awesome series. She's a very intelligent woman. She's always got something awesome to say. I learn every time I talk to her, so I'm sure you guys will too. For the rest of the night, I don't really have anything for you. John will take over, And I just want to give a quick thanks to Chris in the background, our awesome visual effects, media / audio / artist extraordinaire. If you guys like his stuff, go check out Ransomware. It's awesome. That's all I got for you guys. I'll let it go to y'all now. Thanks for tuning in, everyone.
This new series, we're going to be going down the HTTP request smuggling rabbit hole tonight. So without further ado, let's get started. So first of all, I want to let you know that this talk is sponsored by the Neon Temple. The Neon Temple is a cybersecurity guild located in Tampa, Florida. We have different tiers of members, and it's a great place to network, learn new stuff, make friends, and get jobs. So if you're interested in learning more about it, go to the website, or you can follow us on Twitter. So the agenda for tonight, and I just want to preface by saying this is a series. This is not something that we have to hurry through. So if we only get through 3 labs tonight in the 45 minutes, that's perfectly fine. We can just stick a pin where we left off and pick up next month. So this topic, I will warn you, it is not easy. This is definitely an intermediate to advanced topic. However, I'm hoping that the way we interact with each other and everything, that you guys will take a lot away from it. So the first thing I want to do is level set on what HTTP request smuggling is. Then I'm going to show you the detection techniques that you can use when you do penetration testing, and also confirming that the vulnerability is there. Then we'll look at some actual attacks that we can do, like once we find the vulnerability, okay, what can we do with it? Then we're going to look at the different protocols that HTTP smuggling supports. And then finally, we'll talk about how do we mitigate this problem. So what is HTTP smuggling? So I've defined it this way. It's an attack which tricks websites to serve arbitrary requests, obviously arbitrary requests being attackers' requests. Now, the technique is accomplished by confusing the way that web servers read HTTP requests. So this is you're the attacker, and you have a legitimate regular post request right here. But what you're going to do is you're going to append another request to that request. And you're going to present that to some sort of front-end device. So this device could be a reverse proxy, it could be a load balancer, it doesn't really matter what the device is, but you have to have at least 2 devices. So this front-end device is going to take HTTP traffic and is going to serve it to this back-end web server. So this is the web server here that actually is hosting the application. So the idea here is the attacker is going to trick this front-end device to place his smuggled request on the queue of requests, so that the web server doesn't really see that it's been smuggled in. If there's any questions, just let me know. So you might be thinking to yourself, well, what is the point in trying to smuggle in a request? So right here, I've got my purpose. So you're trying to bypass these front-end devices so that you can get your ambiguous request to basically do something on an internal server and give you a response back, from the front side. So it's this confusion that we're trying to cause in order to get a response from an internal server that we shouldn't be accessing through the internet. So the impact of this is bypassing security controls. Obviously, that could be WAFs and other detection mechanisms. We could gain unauthorized access to sensitive data, and we're going to talk about that because there's a way that you can get other people's responses in all of this, which means you could be seeing their sensitive data and or compromise other application users. So a little more explanation here. So here we've got our front-end server. Once again, that can be an RP or an LB. And we've got our back-end server, and that's our web server. So this is our smuggled request, this whole thing. Now, what you're going to do is you're going to start with a post, like standard post. In fact, it could even be in a lot of the labs that you'll see, it could even be a get that we just quickly change and burp to a post. So, but the smuggled part is going to be included in that request at the bottom. And in this particular case, we are trying to bypass some security controls so that we can see the administrative console on an internal network. So these should never be available like Tomcat or Apache or Nginx. These things shouldn't be available directly through the internet. So this is a way that we can smuggle in a request to see if maybe we can get access to that. Now, what we're hoping is that this web server on the back end looks at this one giant request and says, no, that's not right. This is actually 2 requests. So I'm going to treat it as 2 requests. And that's what we're looking for. Now, some of you might be inquisitive and think, well, the spec shouldn't allow that. The HTTP spec shouldn't allow you to smuggle requests in. And you would be correct. So the actual verbiage for RFC 2616 is if a message is received and it has both transfer encoding, and we'll talk about what these terms mean, transfer encoding and a content length header field, then the transfer encoding overrides the content length. Such a message might indicate an attempt to perform request smuggling or response splitting. So what exactly does this mean? It means that if the 2 headers are in the same request, then the device should pick the content encoding and not read the, then the device should pick the transfer encoding and not read the content length. So some of you may still be a little confused. So let's just take a step back for a moment. Let's talk about the standard HTTP behavior of how requests are read. So there are 2 headers that determine when a request ends. And that's really what this is all about, is we're trying to figure out, or the devices are trying to figure out, when does the request end? So in a post, if you have a content length, and this is the only header here, then it's going to specify in the number of bytes. It's going to specify with a number, the number of bytes that's in the post body. So down here is our post body. And so this number is going to correspond with what is there. You'll notice there's no transfer encoding header. So, but on a transfer encoding, you notice there's no content length in this one. And that's why I have this no CL here. But with the transfer encoding, what it does is it reads chunks of data. So it reads bytes in chunks. And the first thing that it'll do is it needs a hexadecimal representation of the number of bytes. So in the first part of the body of the message, it's going to have some hexadecimal number. In this case, the number 24 is 34 bytes. So this is the exact same body that we had here, right? It's exactly the same message. It's just I'm showing you two different ways that you can send it with these two different headers. Hopefully that's making sense. Do we have any questions so far? Okay. All right. So far, so good. All right. So what we're trying to do is we're trying to cause this confusion in order to smuggle in another request. So what you do to cause the confusion is to add both headers to the same request. So what this does is it, depending upon the implementation of how the device was written. So there's software in the device, right, that is going to use either content length or transfer encoding. But as we all know, even though the spec said do this when both are presented, manufacturers can interpret that differently or implement that differently. And we've seen that in other software as well. So that's kind of what this attack is hinging on, is that there's a nuance in the way that the front-end device is reading when that request ends to send it to the back-end device. So here you can see an example. Here we have just a standard post, but we're presenting to the front-end server both headers. And when we talk about content length and transfer encoding, instead of having to say those words each time, we just refer to them as CL and TE. So you'll see that a lot in the subsequent slides and in the labs, where they'll just talk about this CLTE, and that is what they mean, the two headers. So there's a technical term for this confusion. It's called desynchronization. And let me just see here. So it's called desynchronization. And depending upon the size or the completeness that of the smuggled request, depends upon how that request is going to be treated. So let's say that there's only like the letter G that goes through here. Now the front end is going to think that the smuggled request is its own request, gives it to the back end, but the back end looks at the G and says, well, that's kind of not really a whole request. So I'm just going to concatenate it with the next request. So the next request, it gets off the queue and it concatenates that together. So it becomes a prefix for the next request. So let's take a look at some examples. So in this particular scenario, our front-end device uses CL, or content length, and our back-end device uses CL. So this scenario is a CL-CL. So that means the front-end device uses this first header and it reads 6 bytes, which means it's going to read everything in blue, including the orange G. But when the backend device reads this, it's only going to read the first 5 bytes, That's the first request. And then it thinks that the G is the second request. But the problem is G is not a complete request. So what it does is it appends it to the next request that it receives off the queue, which in our case is going to be another post. So it appends that. Well, the response that you get, the HTTP response that you get back, is unknown method G post, because it appended that G to the next request and it said, well, I don't know what that verb is, so here's your response. I don't know what to do with it. And if you feel like you're getting lost, like, well, what does all this mean? Just hang on, because I need to explain the mechanics to you first, and then we can get to what the attacks can actually do. And it's really cool. Okay, so now the next one, the next type of confusion is CLTE. So here, the front end is going to read the content length, and the back end is going to read the transfer encoding header. So let's see how this might work. So the content length is 6. So that means it's going to read all of this. So all of the blue, which actually there's more here, and the G. It sends it to the back end. The back end is only going to read the 0, and then it's going to think that the G is the start of the next request. It's not complete enough, so it appends it with the next post. So once again, the response you get is, well, I don't know what this verb is, G post. And then there's the confusion technique of TECL. So this is where the front end device uses transfer encoding and the back end uses content length. So in this scenario, the transfer encoding, of course, this is our hexadecimal representation of 6 bytes. So it's going to be all of this, and then it terminates with a 0. But then the back end is only going to read 3 bytes. So that means it's going to only read this 6. Now you might be thinking, well, that 6 is just 1 byte, but actually it's 3 bytes. Because the carriage return and the new line on that line count as 2 more bytes. So you actually have 3 bytes here, which is why this matches up. Okay, I want to just pause there for a second because that's a lot to take in. Does anybody have any questions or comments? Nothing so far?
I'm not seeing anything in Discord.
Okay. Alrighty. Well, we'll keep going. Okay, so we are back to doing our attack. And this is you. You're the penetration tester. And you want to smuggle in request 2, and you're going to obviously have that as part of request 1. The front end looks at that and says, yeah, sure, I'll put that on the queue for the back end to read. The back end reads it and says, okay, I've got request 1, and I've got request 2. Not really sure what to do with that request 2. Request 1, yeah, I'm going to give a response for that. That's fine. But my response for 2 might actually generate 2 responses, because remember that G was kind of weird. It didn't know what to do with it. Or in the case where it's a full request, like the get admin, then it could still generate an additional response, right? So in HTTP, you always have, for every 1 request, you get 1 response. Well, because we're poisoning the response queue, if you will, you're going to end up accumulating more responses on the back end than what matches what came in on the request queue. So this is where it starts getting quite interesting. Now, if you're only attacking yourself, well, that's not terribly interesting. However, once you have more users on the application, then you're going to start looking at some data that could be quite valuable. So here we have our situation again with the smuggled request right here. We get the first response, but the response for this request actually gets sent to a different user, right? Because we've poisoned the response queue by flooding it with an extra request. And then guess what? The response for her request, well, that can be sent back to the attacker. So you have this situation where somebody's information, such as their session cookie and things like that, could be sent to an attacker for session hijacking possibilities. So we're working up to the first lab, and what I wanted to do is I just wanted to make sure that everybody feels comfortable with the way to do the counting. I'm going to show you the manual way, and then I'm going to show you how you can like cheat and just let Burp do it for you. So content length, as we've mentioned before, CL, that's going to represent the number of bytes in your post body. For transfer encoding, everything is read as chunks of data. The first thing that needs to be done is to represent the amount of bytes with a hexadecimal representation, and then you NTE with the trailing 0. Also remember that the carriage return in new line counts as 2 bytes. And I'm going to show you in Burp how you can easily see this. So we're at our first lab. So basically, I was going to kind of do this lab with you guys because it's really just about showing you the counting and how it's done. So I want to make sure that everybody has an account for PortSwigger, because you're going to need that in order to do the labs. This particular lab we'll just do together, but for all the others, you're going to need that PortSwigger account. So I'm going to show you on the slides, and then I'm going to show you on my laptop inside of Burp. But for the slides, here you've got a content length of 6. Now, you never count the space between the very last header and the beginning of your request. You never count that. You start counting like here on line 7. So the 0 and then the carriage return in new line, that's 3 bytes. And then you've got another carriage return and new line. So that's 2 more bytes. And then you have the G. So that makes up your 6 bytes. But this is how you can do it inside of Burp. If you just select the lines that you want, and then you look over in the inspector, it'll show you that number 6. So I'm going to stop sharing the slides, and I want to share Burp. Okay, so I want to show you here. I have just a standard post, and I am doing the desynchronization here. But you can see that the content length is 4. But also with the transfer encoding, we've got our hexadecimal representation. So what you can do in Burp is there's this little new line icon. If you click that, it will show you the carriage return and new lines so that you can more easily see how the counting is done. But as I mentioned before, you could also just do this, and then you can see right here. So I don't know if you can see, if you can follow my mouse, but right here is the 4. So that corresponds with the content length. So that's really the first lab, is just getting you familiar with how you can see that this counting is done. All right. I'm going to go back to the slides. Give me just a moment here. There we go. Okay, so now that you understand the mechanics of CL and TE and how devices will use one or the other, they'll look at that header in order to determine when a request ends. Let's look at the different detection techniques. So what you can do with these is you can mix and match, and we sort of went through that already with some examples. The subsequent labs will be using these different techniques in order to identify whether the vulnerability is there or not. So what you're going to do is you're going to place both of those headers in the same request. The request needs to be a post. Once again, you can start with a get, and you can just in burp quickly change it to a post. What you're hoping to find is when you place these two headers, you're hoping to find some sort of time delay. The time delay means that that backend web server is thinking about how to parse that. Now, I'm just going to tell you, though, that you could get other responses. So James Kettle, who was the one who really perfected a lot of this, he has had almost all of the, he's notified almost all of the manufacturers of front-end devices, and they've patched for this. However, there's always a chance that things aren't patched, or that there's some nuance, or there's also HTTP2 downgrading, which we'll get to later. So I don't want you to feel like you don't have the possibility of this happening. It can still happen. But I do want you to realize that you might not always get that delay. You might get some other strange responses. You could get like a 500s. You can get 404s, you can get 403s. So, but the rule of thumb is you always want to start out with content length attack first. So remember, I told you could mix and match them. So you can do cl.te, or you can do te.cl, where you always want to start with cl.te first. And the reason for that is if you do the TECL first, you're poisoning the response queue. And so you may not be able to ever get to do, like, if the device doesn't support that, then you're not going to be able to go backwards to the CL, because you've already kind of messed things up. So always start with the CLTE first. So if you want step-by-step instructions, you're going to send 2 requests. And you'll see this in the lab. You've got to send things twice, because once again, you're smuggling a request. So you're going to have an extra response. The first request is ambiguous. It's going to create this malicious prefix. The second request should the second request should get poisoned from the malicious prefix of the first request, and as a result, you're going to get a different response. If other users are active in the application, then you could possibly get their response. And there's some definitely some interesting use cases that I'll be sharing with you, some actual bug bounties that have been done, and some interesting things that people have done with this. So the CLTE technique is you are going to hope, and of course we don't know, right? This is part of the shot in the dark thing. You don't know what the front end device is going to use, if it's going to use CL or TE, but you want to start with this attack first. So you start out with your content length. You'll have both headers, but this is going to match the body of your post as far as the number of bytes. Okay, so before we can do any of the labs, there's something that Burp does for you that you need to undo. Otherwise, you're not going to be able to solve the labs. So in Repeater, there's an update content length that's always turned on by default. And you need to uncheck this when you do smuggling, because you don't want Burp to automatically read the number of bytes. The whole purpose of this is that you're manipulating that so you can sneak in your smuggled request. So if it's not working for you, it's probably because of this. So make sure that you turn this off when you go to do the labs. All right, so ready for our first lab. This is lab number 2, the basic CLTE vulnerability. So do we want to give everybody a few minutes? I think what I'm going to do is I'm going to kind of get everybody going so they can sort of get in the rhythm of this, because I know it is a little bit odd. So the first thing you want to do is log into your Portswigger account, and you want to start at the top here. Okay, cool. So you want to start at the very top. So this is HTTP request smuggling basic CLTE vulnerability. Now what I do is I like to open these in a new tab so that when I go to access the lab, it opens in a new tab. And since we're coming down to the last 10 minutes, what I'll do is I'll just sort of set it up for you guys to make sure that you're on the right track. So let me go here. So what I do is I just start here and I put things side by side like this so that I can see everything easily. And then you're going to literally just go through the solution here and do this solution. Now make sure, while I've got your attention, make sure that this update content length is not checked. Okay. So what do we say we give everybody maybe 2 minutes to do this one? It shouldn't take too long. Do we have a timer? Guess I can get a timer. Oh, okay. Yeah, about 2 minutes. Okay, great. Well, let's go through this together, and then we'll probably call it a night. Okay, so what you want to do is you want to just go to your proxy history, and I usually just grab the first get that's there, send that over to repeater, and then we take a look at the solution. So it lets you know that it has to be a post. Well, this is easy to do in Burp. You just right click and change the request method, and it automatically changes it to a post. And then I leave this out because my lab my lab ID is already there, so I don't need to copy that. And then just grab the rest of this. And we'll go through what it says in a moment. So once again, you want to make sure that you've got the spaces there. You can turn on that little icon so you can see. But then you're going to send this twice. 1, 2. And you can see what happens is the letter G was sent as our smuggled request, but when the backend server received that, it didn't know what to do with it, so it hung on to it as a response, and then it appended as a request, and then it appended the next request to that. And so we got this weird response that says, hey, I don't know what this G post verb is, so I'm just going to give you some standard response. In this case, it's a 403. But that's how we did that one. And this was the CLTE. So we were focused on our content length and then the transfer encoding. So I think that's a good stopping point. Are there any questions or anything I can answer? How about in YouTube world? If not, then okay. Well, I can close this out, or maybe Trey wants to close this out, or I can. It's okay. Okay. Sure. Yeah, that's a good idea. So the next class that we'll continue on this topic, and we will meet again. It'll be on a Wednesday night next month, the 22nd. So June 22nd, and we'll continue on this. If you didn't have your Portswigger account, make sure that you've got that. Make sure that you've got Burp. I'm pretty sure that almost everything that we do doesn't really require Pro. So all of these features should be available in Community, if that's a concern of yours. And I think that's about it. So I thank you all for your time and attention tonight, and I hope you enjoyed it. Have a great night.